Let's begin by having a general discussion on how a test case design should be sketched. So the test should really manipulate the relevant objects, of course, by creating them and also invoking methods on the relevant context objects. And let's say for test case number 1, we want to initialize a counter object C with the value 0, the minimum value, and then we want to call upon C.increments. And second test case, we may want to initialize a counter object C, but rather than incrementing its value, we want to decrement it. So here you can see the different natures of these two test cases. For the first one, what do we expect to see? We expect the value to be incremented from 0 to 1, which is legitimate. On the other hand, the second test case over here, if we actually attempt to really decrement the value from 0 down to -1, we should really expect to see some value too small exception at the moment, right? So you can see the different natures of these two test cases, and that would be the focus for the rest of the this module here, to really show you your test case does not necessarily always have to test something that should work, but also when the erroneous conditions actually occur, your implementation should also throw some exceptions as expected. Let's see, what do we expect to happen? Given what I just said to you verbally, let's now see. For the green one over here, what do we expect to happen? Well, we definitely should expect the value should really increment from 0 to counter the minimum value, which is 0 plus 1. What about the red one over here? So in this case, what do we expect to happen? Rather than expecting the implementation to do any updates in such erroneous conditions, given that it actually violates the requirements for the counter. Remember, the counter value should never go below its minimum bound. So what we expect to see is the value too small exception is thrown. You can immediately think about a symmetric erroneous case, which will be, let's say if the value of the current counter is already its maximum value 3, if you attempt to really increment the value, in that case, you would expect the value too large exception to be thrown, right? It's kind of symmetric. And what does your program actually produce? Up to now, it's only about conceptually what we hope will actually happen as expected, but your actual implementation may not actually implement faithfully with respect to the expectation, in which case the test cases will be very valuable if they can reveal if there's any errors in your implementation, which is something I will also demonstrate to you both on the paper, on the Eclipse. So what does your program actually produce? How do we find out? Well, we have to somehow manipulate the relevant objects in order to find out. So we have to call maybe C.getValue to find out. In this case, we want to make sure C.getValue is really incremented from 0 to 1. And in this case, C.getValue should not really be changed. Instead, the execution flow should be disrupted, and then the exception should be thrown. Okay, and then for the second one, for the red one over here, how do we actually test to see if the expected value too small exception is really thrown? We have to use some particular design involving a try and catch block, and this is to be discussed, and this might be something very new to you, and I would like to explain that to you and illustrate it in detail. Okay, a test will pass if the expected outcome occurs. So here, when I say expected outcome, it includes two possibilities. For example, expected outcome number 1, the value of the counter has been incremented as expected, and number 2, the expected outcome could be that I expected some exception to be thrown, and indeed it was thrown from the method. So both are possible, but we'll see. We have to distinguish between them very clearly. And of course, the test will actually fail if the expected outcome does not occur. Specifically, if I expected this particular exception to be thrown under some erroneous condition, but it did not. But it was not thrown by the method. In that case, we can reveal the error about the implementation. Keep that in mind, and then we'll see illustration of that. Okay, so to start with, we are simply going to develop test cases using console tester, and then later on I'm going to address its limitation at the end of the several examples, and then I will move on to JUnit test cases. It's always good to actually go over some intuitive and maybe naive solution that's kind of straightforward. But we can definitely discuss some logic about the test design. But after that, we have to move on to the more ideal solution. So that'll be the flow.